With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says a block of wood floats in fresh water with 2/3 of its volume submerged. In oil, the block float with 1/4 of its volume submerged. So we need to calculate the density of oil. So let's try to understand the given question with the help of a diagram. So here we can see two situation is been shown over here. In the first, the block is submerged 2/3 in the water, and in the second case, the same block is submerged in oil with 1/4 of its volume inside the oil. So we will take both the cases one by one. As we know, when the block is been submerged in the water in the first case, so the weight of the block will be acting in the downward direction. So let's suppose that capital W is the weight of the block and which is acting in the downward direction. And also the block must be experiencing some buoyant force or upthrust force from water. So let's take it as to be F. So we can write under the equilibrium condition. For case 1 we are writing under equilibrium, we can say buoyant force will be equals to weight of the block. Alright, so buoyant force can be written with the help of, let's write it as FB over here. So buoyant force can be given by the formula of by the concept of Archimedes principle. So buoyant force is nothing but weight of the liquid that has been displaced. So if we write weight of the liquid displaced, so we will write it as mlg, that is weight mass of liquid into g, and here mass of liquid can be written as density of liquid into the volume of the liquid that has been displaced. So volume of the liquid displaced will be nothing but it is the 2/3 of the block. Let's suppose the volume of block as V. So this volume of liquid displaced will be 2/3 of V. So we will write it as 2/3 of V into G. So this is the weight of the block we have calculated. So let's say this is our equation number 1. Alright. Similar case we will follow for the second case. So here we can see for second part we can write the same block is now been submerged in the oil. So again we can say under equilibrium we can write weight of the block will be equals to the buoyant force. Now the buoyant force will be something different because the liquid over here is oil now. So we can write m of oil into G, and again this can be written as rho of oil into the volume that has been displaced. Now the volume displaced will be this much, that is 1/4 of the block V, that is we can write it as V by 4 into G. Alright, so this is the second part of the question. So from 1 and 2 we can say, from 1 and 2 we can equate these two, both are the weights. So we can write rho L into 2 by 3 V into G, and that is equals to rho oil into V by 4 into G. From here V, G will get cancelled out. Therefore we can write rho liquid, that is rho water, we can say it over here as, so it is 1000 kg per meter cube into 2 by 3 into 4, and this gives us the value of density of oil. So after solving this value we can write it as 8000 by 3, and that is equals to, so we can write it as, therefore the density of oil can be given as 8000 by 3, and that is equals to 2666.67 kg per meter cube. So this is the density of oil we are getting, and this matches with option A. And I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.